Let's see. You guys ready? Class?
Yes.
Wow, that was weak. Come on now. That was pretty good. I heard you there. Yeah, I didn't hear you back there. Back row? Better be hearing it. Let's try it again. Class?
Yes.
All right, that's better. Okay. So what page are we on these notes?
33.
What is it?
33.
30. So I told you guys it's the last section in this unit. And so after this, we're going to be taking a test. And we're also doing the notebook checks. So your notebook should be in good order all the time. So please make sure you are, staying on top of your notebook. Don't be that person that takes like 5 days because you didn't do anything the first day. Okay, just put it all in. Tape is somewhere around there. Make sure you update your table of contents as you go. All right, so 12.6, scatter plots, correlation, and regression lines. Now, if you just look at the homework real quick, if you could please. There's only 8 questions. I only wanted those 8 questions. That's it. That's all you're going to have to do. It's just do the problems. That's it. You're good. So I didn't want to put anything else except for how to do these. So it is a short homework assignment also. So a lot of objectives to go along with this. Scatter plot and correlation. Scatter plot is a collection of data points, one data point per person or object. So these are referred to using an X and a Y. So this is actually going to be in a graph, scattering through. I'll show you here in a moment. Okay, it can be used to determine whether two quantities are related. So correlations, a clear relationship between two quantities. Used to determine if there is a relationship between two variables, and if so, the strength and direction of that relationship. So strength has to do with my R value. Is the R value strong? R value close to 1 is a good one. 1 meaning 100%, all my data points fit exactly on my line. That's what 1 is. That is a strong correlation. Positive would mean it is giving a direction of the correlation. Negative, it would be going down correlation for that. Here is an example of a scatter plot. We have a bunch of dots. If there's a clear relationship that the quantities are said to be correlated, so if you notice, going from left to right, is there any correlation, do you think, to this? Do they tend to go in the same direction? They look like they're kind of all going up, right? As I go to the right, as I read it going to the right, it looks like it's going to be going up. So that would be a positive relationship, right? And it looks like there is somewhat a correlation. So can I draw a line somewhere through and be close to all those? Yeah. Okay, we need to figure out the strength of the correlation later on. Scatter plot shows an upward trend among the data points, although there are a few exceptions. People with increased age tend to have higher blood pressure. Correlation is not necessarily causation. So just because that it does tend to work out, it doesn't mean that that is the reason. That's what that means. So, correlation is not necessarily causation. My blood pressure is not high. I am over here in this category, right about here. I have low blood pressure. Lower blood pressure. So it's actually in the medium to low range normally. Okay, I don't eat fast food, so that's one thing that helps. I don't drink sodas. That's one thing that helps. Okay, other people, let's say for instance, you just went to McDonald's and got you one of those Mick Cancer, whatever it is. I don't know. What do they serve there now? What do they serve in the morning? Mick Cancer? Yes. Okay, yes. They gave you butt cancer. Okay? So, you, with all that salt, all that sodium, all that processed food, might actually even have higher blood pressure than I do. And I'm over here on this range. You people are way down over here on this range, way over here. So, correlation does not mean causation. So, just because I am right here doesn't mean that age would be the reason for my blood pressure. That's what that means, right? So, there could be other things. Regression line is a line that best fits the data points in a scatter plot. So, you know that red line that I just drew up there? That's the regression line. It's a straight line that actually fits all those points. Yeah, there we go. Correlation coefficients. Designed by R is a measure that is used to describe the strength and direction of a relationship between variables whose data points lie on the or near the line. Relationship is positively correlated if they tend to increase or decrease together. Negatively correlated if one variable tends to decrease while the other increases. Decrease while the other increases. Does that make sense, doctor?
Huh?
Yeah?
Yep.
Agree?
Yep.
Okay, good. Perfect position correlation, in which all points lie precisely on the regression line that rises from left to right. Perfect negative correlation, in which all points on the scatter point lie precisely on the regression line that falls from left to right. So it's going down. Yes? Hopefully. Good. So here is some examples so you could actually use to identify what each one would be. Perfect positive correlation is right here. They're all going up. Down here at this last one, it says perfect negative correlation. They're all going down. And there are examples somewhere in between.
Pay attention to the R values down there below the pictures. Notice how the one that says 1 got a really straight line, and as it moves away from 1 in the negative or positive direction, those dots begin to spread out.
And once we get to negative, it starts grouping back up, but going into a straight line again. All right, so look at this. Man, this is easy. Isn't that right? Look at all that. Bunch of Greek letters and all kinds of crap to go along with this. Do you think I'm going to show you an easier way to do it? Yeah, okay. So it's a sum, so n times the sum of x times y minus the sum of x times the sum of y, and then the square root of each multiplied apart, blah, 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 blah. How about let's do it with a calculator? You want to do that? All right, calculator is my friend, right? Not food. So I know you people, like Roman, is going to make sure that he's writing down the steps for the calculator here. All right, so I am going to go to a new document. On mine, I have to go, there we go, document, and there we go. All right, new document. So home 1, list and spreadsheets is what I want. Right, Roman? Did you write that down? So we're back to list and spreadsheets. Now, my x values. So on my graph, my x values were given right here. Age was my x values. So remember, we always have to name them at the very top. So this is age. And this other one, I'm just going to call it blood. Because I don't want to write the whole thing out because I'm kind of lazy. So we have those two things, and let's go through and start entering my values for age, which was 37, 39, 42, 44, 47, 48, 50, 51, 52, 54. And then enter my blood pressure, 133, 143, 135, 151, 143, 158, 163, 146, 168, and 160. Now, this one's going to be slightly different than what we've done before. All right, you ready? All right, so slightly different. So this time, document, insert, data statistics. I know we're writing these down because it is slightly different, but it's going to make your life a whole lot easier when we do all the regressions. All right, now that we wrote that down, so let's tell you what it looks like. Now, it's a mess, right? So now, click on the bottom. What was the variable on the bottom? What was my x value? Age, very good. So I'm going to put age there. And now, what about over here on the y value? What was my y value? Blood. There we go. We're running a little bit slow here. Looks neat, right? So now I have my data. Now let's try and figure out what the regression line is. Menu. Come on now. Uh-oh. Why you no worky? All right. Try it again. Menu. There we go. Analyze. And what do you think I'm looking for? Regression, right? So that's the one we're looking for. Analyze, and then I want the regression. And then there is a whole lot of different types of regressions that you could do. And what we're currently working with is linear. So we're going to do a linear regression, which is right here. And so what does that give me? That gives me my equation. There is my line for my regression. So my calculator did it all for me already. So now I have my line. So let's say it's going to be 1.66x plus 72.93. There we go. So if you notice, I skipped a whole bunch of pages that were all the equations to get from there to there, right? So we have our equation of the regression line. Now let's find the R value. Let's find the strength of this regression line. Let's go back to the calculator. And I'm going to do document, insert, calculator. So document, insert, calculator. Give you a second to finish writing it down. All right. Now let's see, menu. So once we get to our calculator page, what are we trying to do here? We're trying to do statistics. Stat calculations. And what did we just do? We just did the linear regression, didn't we? So the calculator is doing everything for us. We just need to know on what page we could ask him that. So my X value was age. My Y value was blood. Save the rest. Okay. And the value I'm looking for here is my R value. So my answer comes out to be 0.79. So what does that tell me about it? Think about it as grades. If that's a 79%, is that a good grade?
Yeah.
It's not bad, right? It's not bad. It's not 100%, but it's not bad. It's almost a B. So it's not too bad. Is it positive? So if it's positive, it means it's trending which way? It's going up. If it was negative, it would be going down. But that 0.79, that's not bad. That's not a bad correlation. That's okay. Make sense? Questions, concerns, complaints? All right, so there's a couple other things here, but let's look at this.
Just drop this stuff off.
Okay.
It's for advisory.
Approximate blood pressure to the nearest whole number corresponds to an age of 60. All right, so we're going to go back to our graph. So our graph, if you recall, was on the previous slide, right? So it's 1.2 up here. Yes? We're going to that. Menu. I want to analyze graph again because I'm looking for age of 60, right? Analyze. And I want graph trace. Again, there is a lot of step-by-step here, so I'm trying to give you time to write this down as you're going. So analyze graph, graph trace. So we're tracing the graph now. So there's the little X that popped up on my line, and I want this X value right here, which is currently 46, to be what number? 60, right? So just start arrowing over until you get to 60. And it says round it to a whole. Ah, I lost it again. Ah! Why has it got to be so difficult today? What do we get? 178. Menu.
173.
170.
172.6.
Okay, 172.6. $172.6. All right. So you're going to have an approximation just like me. So we said my coordinate is 60 and 172.6. To the nearest whole number would mean that this is going to be 60 and 173. Because that 6 is going to make it round up anyway, right? Make sense or nonsense? All you have to do is put stuff in the calculator. All right, and the rest of this other stuff, I am just gonna not do it because it's not necessary. All right, you guys, like, share, and subscribe. Hit that notification button and support my channel. Buy stuff from my merch store, right? Support my Patreon.